Hello and welcome everybody. I'm Tony Seale from the Knowledge Graph guys. Obviously, there's a lot of Knowledge Graph guys here, so I feel like I'm at home. An Englishman in New York, but at home. I don't think the clicker is actually working. This one. Perfect. Yeah, I'm here to talk about DPROD, which is the Data Product Standard, but I'd like to start by setting the context of where I believe that we are. And I think that we're entering a phase of exponential change. AI is somewhat overhyped, but at the same time, we shouldn't not think that something very big is going on. And how big? Well, I think that we can see the change that we're about to go through now as at least as big as the agricultural or industrial revolutions. So this is the size of the challenge which is sitting there, and is the kind of background to what all businesses need to be thinking about. And also, I believe that as part of this change, this graph community has an important role to play. And this is what DPROD is an attempt to do, to provide a bit of an architecture that we can come together around in order to share our knowledge and contribute to what's about to happen. And I think really make a very important contribution. You see, when we look at AI and we see the glittering algorithms and what they're capable of doing, we're simply looking at the very tip of the iceberg. The underlying mathematics of the transformer is actually rather simple. So there's a question of, like, where is all this power coming from? How are these models so powerful? Well, I think the answer is simple, that the power is coming from the data that underlines them. Because we, the people, decided to put all of our information in textual format out onto the web. We shared with that. We came together as a distributed global community. We linked together with hyperlinks. We took our knowledge, we shared it, and as a collective effort, we took our intelligence and we put it there on the web. And then what the foundational models have basically done is that they've taken that collective intelligence that's been shared on the web in textual format, and then they've condensed it and crushed it down into a series of floating point numbers within a neural network. A lot of floating point, trillions of them, but still way, way smaller than the web. They've compressed the knowledge of the web. And now as organizations, we're facing a situation where intelligence is growing exponentially, as we were talking about, and can now just be imported into your organization. So in a world where general intelligence is growing exponentially larger, what is an organization to do in order to survive through this phase transition that we're about to go? And I think that there's a lesson to learn here. There's a deep pattern, because when we put the information onto the web, we had the standards of HTML, HTTP, and URLs. And that allowed this collective collaboration of a global community in order to encode our information in text on the web. And it's that process that actually sits at the heart of things. And that's what organizations now need to do. They need to focus on their data, and they need to focus on finding a way to connect and consolidate it, to allow information to be connected together within their organization. But we've got a problem. We've got a huge problem, because certainly within most large organizations, or even medium-sized ones, anyone that's got more than 100 databases or lots of text files, this information is currently in a terrible mess. It's completely disorganized. It's a spaghetti of different connections. It's poorly standardized. It's not well organized. It's not discoverable. It's not well understood. And if we're about to head through this exponential change and we have to focus on our data, then we can't any longer think in this kind of siloed application mentality where an individual developer is looking after one database and then exporting entropy out into the rest of the organization. Instead, we need to take a holistic view of what is the total data estate of this company. You know, textual documents, structured information, unstructured information, it's all information about your company and it should all be connected together. How do we go about doing it? Well, one way that we don't go about doing it is through a centralized mechanism, because this is what we've been trying for the last 40 years, you know, first of all with data warehouses, then we had the data lakes and then data lake houses, and you can pick whatever kind of watery metaphor that you want. The problem is that a centralized solution, even a graph database, we all love graphs, but you stick a centralized graph there in the center of everything, it's not going to work. And this isn't a technology problem, it's a human problem. You can't centralize human collaboration. It was what made the web so powerful was the humans that encoded their information in there. And we need the same thing to happen here. And you can't centralize human effort. So we've seen the disordered system. This is where most of us are at the moment with our disordered data. We've tried the centralized model, and we've seen that that doesn't work. So we want this third way. We want decentralized organization. So, okay, that sounds good. Well, what do we mean by it? And I think an example can be quite helpful here, because when the former USSR was dissolving, one of the commissioners from Russia came over to the UK to see the institutions of how a free market is working. So go visit the London Stock Exchange, and he was taken to these various different institutions. But at the end of the day, he came back and he said, look, yeah, fine, I've enjoyed this tour, but really what I want to meet is the guy who is responsible for managing your bread supply chain, because I haven't seen a single queue outside any of your shops for people queuing for bread. Who is this guy? I want to meet him. He must be a complete and utter genius. And of course, the answer was, there is no guy. That's the invisible hand of the market operating there. It's self-organizing this system, this decentralized organization. So the answer is obvious then, right, in terms of what do we do about data? How do we organize our data? We need a free market for data. Of course we do. We want market forces operating in there. So within every internal organization, we want to create a data marketplace where people are thinking about their data as a product. And this is not new news. Pretty much every large organization I know now is working on, they have spun up data product teams, and they're organizing themselves around data product teams. They're taking the data that they've got in existing databases and they're creating data products here. And this is great, this is good. This is the start of a solution. This is the right mentality, because now we're saying to people, think about your data as a product, package it up and make it available for the rest of the organization. But it's kind of a philosophy, really, and a bit of branding rather than any actually sort of strong implementation detail. So what does the implementation detail of a free data market look like? Well, let me give you and start with this insight. Functioning markets need standards. It's actually through the centralization of standards that decentralized markets can function at all. You want to keep that standardization light, of course you do, but it's actually by centralizing those standards that the market functions. These are the common terms that we can operate under. And it turns out that one community out there has been thinking about decentralized data standards for an awful long time. And first of all, we were called the semantic web, and then we called ourselves linked data, and now we call ourselves knowledge graphs. And the depth of intellectual effort that has gone into thinking about this problem is beautiful. If you kind of look at all of the work that's gone on in the universities and the applications of it in various different situations, some of the people sitting here in this room are part of this incredible intellectual endeavor to really get at the problem of decentralized data integration. Because the thing is, people say that the semantic web is complicated. Oh, the semantic web's so complicated. It's not complicated. The problem is complicated. Decentralized data integration is a gnarly, hard problem. It's a really, really hard problem. And the semantic web, linked data, knowledge graphs, they have an elegant solution to that problem. It's so elegant, we can pretty much break it down to two principles. So first of all, any market needs some form of standard identifier. You have to have a standard identifier. So barcode, license plate, ISIN, IBAN, whatever. We have to uniquely identify these items. And the semantic web takes a very simple approach to this. It takes the tried and tested technique that allowed us to collaborate as a global organization to share and connect information on the web, and it applies it now to the data. That's simple, right? I mean, it's ridiculously simple. We're just going to give each data item its own unique URL. And I am saying URL intentionally here for the experts in the community that know their IRIs from their URIs from their URLs, because ideally, you can take that information and it will resolve back over HTTP. It keeps everything very honest. Second principle then, the second thing that a functioning data market needs, any market needs, is a standard set of terms. Like imagine going to a marketplace to go and buy your groceries or something, and every vendor, they were speaking a different language. Buying what you needed would be an incredibly hard task. Unless, of course, you're English, because the English have a unique solution to this problem, which is that you just shout louder in English. I said I want a loaf of bread. I don't actually recommend doing that. But the example I like to pull out here is schema.org, which is out on the web, and it's a broad but shallow RDFS-based ontology. So in schema.org, what you can do is you can specify different schemas, and here we're looking like a recipe. So the specification sits out on the web, and these are the properties that you can record against what a given recipe is. And then individual websites in a decentralized manner can conform to this. So here we're looking at like the BBC's website, and in the BBC, they've put this little island of JSON LD. So it's just JSON, it's not scary to any developers, but it's JSON LD, JSON linked data. So it's also like a little chunk of knowledge graph sitting there, little chunk of in that format. And the context here is relating back to schema.org, and the type, well, this is person actually. If my example was better, it would have been recipe. But then when the Google search engine crawls over that page, it sees this little island of JSON LD, picks it up and it puts it in the Google knowledge graph. And then when I'm feeling a bit hungry and I fancy a spicy bean burrito, I go search Google, and Google is then able to retrieve that recipe from their knowledge graph. So again, the linked data community has a way of sharing terms, and we call them ontologies and shared semantics. So what does this mean then for data products? Oh, I've given it away. I was going to ask what percentage, I was going to ask a question to you all of what percentage that you thought was actually the number of web pages on the web had JSON LD in it, because like everyone's like, oh, the semantic web failed. No one actually used the semantic web. Global websites, all those millions of websites, half of them have got JSON LD in them. Huge, massive proliferation. Very easy to do. You know, there's not rocket science here which are conforming to this schema. This is not complicated. Anyway, I digress, because we get now to the heart of the talk. We need data products for functioning data markets. So let's take those semantic standards. Let's not reinvent the wheel. Let's take the energy of this great thing that's going on with organizations that's saying, right, we're going to have a data product strategy. We're going to new up a data product team. Awesome. Let's, at this same moment, reuse the standards of the semantic web. And that's what DPROD has been designed to do. So DPROD is a data product ontology. So it's built in these standards that's supplied by the W3C that we've been talking about. It is standardized by the Object Management Group, with its funny acronym. I always crack this joke. It's like, OMG, a standard. And backed by the EDM Council, and as part of what it means to share standards, to share standards within market. We reuse ontologies. This is one of the values of our community. That's what it means. If someone's done a good ontology, you should reuse those standard terms. So we built it on top of DCAT, which was an existing standard that does a very good job of this. So what does this look like then? Well, I'm going to give a unique URL for every single data product that I've got. So within my company infrastructure, different departments and areas can new up their data product, but we're going to give each one a unique URL. And because we're inheriting from DCAT, we're reusing DCAT, what we're saying is that data products will make DCAT data sets available, and we'll give each data set a unique URL as well. So what this means is you have data products kind of swimming in a sea of data sets. They're making data sets available, and they're consuming data sets from other data products. And obviously, when you're specifying your data product, you refer back to the type, which is has got the schema for what a data product is. That's the definition of what a data product is. But you're not now going to schema.org. Instead, you're about to embark upon doing something really, really cool, which is setting up your own internal version of schema.org. So you're setting up a repository within your organization that is going to begin collecting the semantics and the concepts about your organization. And the initial step on this road is to say, I have data and I have a data product, and it's making these data sets available. But phase two is that you then start working out what the semantics are for the data sets that you're making available and linking those back into your internal version of schema.org. And we're just about to see how important that is. Going a little bit technical now, just for 2 slides, just for those people that want the technical details, which I think it's important so that we don't have misunderstandings. So we have the definition of a data product, which has got things like a data product owner in it and the life cycle status of the data product. And that has got input and output ports. This is where you go get the data from. So we've mapped the input and output ports to DCAT data services. So the data service is the connection to the connection string to the database, or the location of the file on disk, or the URL where I can go and pick this data up. Those then relate back to distributions, and the distribution for the kind of data modelers in the room is like the physical representation of this data. So you would have what we call the physical schema there that you can put on there, and it's the format. This is a JSON file. So maybe the data service, I've got a Kafka topic, and I'm making that data available in JSON, say. And then finally, and importantly, you've got the relation of the distribution back to the data set. And this is where we move up to the conceptual level. So off here, we can hang off policies using ODRL. We can go into provenance using Prov. There's a lot of technologies using that are at our disposal here. And a whole bunch of tier 1 investment banks are adopting this and are using it very well to manage this infrastructure. Finally, the data set can conform to, as we've talked about, the type in the ontology. And we'll come back to that a bit more. This is as technical as we go. So this is a chunk of the JSON LD that we talked about. So I've got a bonds database, which has got an API over the top of it. And what I want to do is I want to advertise to the world that I have a data product here. So what I do is I create one of these JSON LDs, just like the website developer did when they were putting a blob of JSON LD in their website. Now I'm registering a blob of JSON LD to be crawled over by the data catalog or the data marketplace to say that this data is available. It's going to conform back with the @context to the DPROD specification. The ID is the URL. Then we've got the data service, which in this case is an HTTP endpoint, and it's going to have a distribution in JSON. And then I've got the information about the data set, and then we've got that kind of conforms to again there. Look, and in this case, I'm saying the semantics of the bonds data I'm making available are defined in the FIBO ontology, and it's a callable bond. It conforms to. That little word there, but really, really shows a lot of power, because this gives us a scalable architecture. This then is an architecture that we can push out across the entire organization, because that conforms to, we have our data products down at this layer with our web scale architecture where you can put as many data products as you want. You just go, I'm going to new up a data product over this application, and that's fine. The data can stay even where it is, but I'm going to put a data product over it. And then the conforms to is linking back into your own internal version of schema.org, your repository of the terms that are important there. And this is the oldest trick in the programmer's book. We're basically creating an abstract interface over the implementation details. So we're creating an abstract interface, in this case, of the business semantics. Who cares what database this thing's in? I'm after a mortgage-backed security, or I'm after a railway track, or whatever the business semantics of that business are, expressed in the language that the business talk in, have those recorded up within the semantic layer. And then via that conforms to, the data products are mapping back into those semantics. So I'm putting a semantic layer over the top of all of that complexity. Okay, and we're going to loop back to AI now. Well, I don't have that much time, but we're going to loop back to AI now, kind of where we started, because it's obviously what I'm talking about here is an awful lot of work. So for a large organization to put data products over everything, to work out what the semantics are of each of those data products, it's detailed. In each case, it's a lot of work. There's no silver bullets here, and I'm not claiming that any of this is easy. I am saying that it's necessary, though. It is necessary, but not easy. But one hack that we can use is we can take the models that we've got now, and we can use them to learn some of the schemas. So you can basically take a large language model, you can point it at the metadata of your database, or if I'm exposing a textual document, I can point it at the text, and I can get the large language model to have a first stab at extracting out what the ontology and the semantics is. And then once I've got that, I can feed that back into the large language model to keep it on track as to what my business is actually about. And there's something very fundamental going on here, because we have the large language models, which at a mathematical level we can think of existing as in a continuous space. They're kind of fuzzy and imprecise. They have conceptualizations, but they're general conceptualizations of what the whole world knows. And they're smeared across all of the weightings within the model. We can take those continuous representation, and we can then bring it out to a discrete representation. So that's what we're doing when we're making kind of an ontological commitment. We're putting a boundary around those concepts. We're going out of the fuzzy world now into a formalization. And once you're in a formalization, you can compute over that, and the responses are the same every single time. We can do deductive logic over it. We can do validation over it, and we can rely upon it. And then that reliability can then be fed back into the large language model. This is not a cracked problem. You go to a certain complexity threshold, and we haven't got all the answers yet. I've recently had painful experience in exactly that. There's more information to learn here. There's more tricks that we still need. But at a fundamental level, I just think this whole thing works out, and it's a strong pattern, which is that basically the LLM looks in at the information here. It's looking at Tim Berners-Lee, and you're extracting out of its latent space a conceptualization. So you're going into a discrete space of what the ontology looks like. Then you get the specialists to look at that ontology and correct it. So that's your kind of human in the loop. And then you can take that conceptualization, which is an abstraction, and you can apply it back to doing other tasks like question answering in large language models, or extracting out your graph or entity resolution. So what this kind of ends up with, and we were just having a chat before about how the term semantics is somewhat overused these days, but what this means then is if I can distill out my semantic layer, and I can connect all of my data products back into that semantic layer, and if that semantic layer expresses the semantics of my business, now I can take my AI agent and I can plug it into that semantic layer. It's like a kind of gateway to the whole of my application now. Oh, someone's asked a question about hospital, the number of beds available in the hospital. Well, I know what a hospital is because I've got the concept in the semantic layer. I know what the beds are, and I can go find you the data products that relate to that, and I can go and answer your question in a precise way. here we kind of get to the essence of what I think, like, we're approaching this phase transition. We're approaching this phase transition. It's going to be this huge moment. And unfortunately, not all organizations are going to make it through to the other side of it. But the ones that do this, I believe, will. Because what it's about, really, is in this decentralized way, as all of the people within a given organization are surfacing up their data products and are connecting their data products back to the semantics. What does this thing really mean? What is meaningful for this organization? What are the most meaningful concepts within this organization? How do they meaningfully connect together? It's all about meaning, and it's all about kind of compressing down into the center, this ontological core. If you like, the distillation, the essence of what this business is, the semantics of this business are all about. And then connecting instances of data back there. Once you've got the instances of data, you can distill models, you can inject into context windows, you can do all the rest of this stuff because you know what the essence of this business is. So general intelligence will increase out, the Gestalt knowledge will increase out as the foundational models suck more and more information into them. The general intelligence will become more and more. But then your intelligence, your understanding of your business, of what is truly valuable within it, what is most meaningful of it, will be compressed down. And if it's compressed down, it will be solid and you'll pass through to the other side. So I think it all comes down to meaning. You know, in a world where intelligence is just about to become incredibly cheap, I think it's meaning. It's meaning that will matter most. Thank you.
And we do have time for a couple of questions.
We have a question from a virtual attendee. So as you said, larger companies now embark on their data product journeys. Probably they have not started with the DPROD, and internal stakeholders may need to be convinced on to embracing it. How would you argue for moving or mapping to DPROD, and should it be actually moving or mapping?
So I think moving on mapping, if you start with that, mapping doesn't matter. Like mapping would be absolutely fine. Why do it? Well, I think we've seen from that thing with Samson there, and we've seen the general moves that are going. Like knowledge graphs are the next stage. Knowledge graphs are going to be the memory for your organization. They are going to be the memory for the AI. So the main argument I would say is that if you're going to go to all this effort of doing data products, then why not do at the same move something which is going to be your gateway to creating your distributed knowledge graph? Really, when you're getting people to specify a data product in DPROD, it's like a kind of gateway drug. You know, you're just saying, can this organization actually agree to share semantics just to say that we have data? You know, is that simple? Can the organization get itself together enough in a decentralized way to say, I have data? And if you can, then you've proved you can do the pattern and you're on your journey to doing what you need to do in order to survive.
Thank you.
Hello, really interesting talk. Thank you so much for it. I'm curious, to what extent do you assume that the data are clean and easily comparable? So I work for a pharmaceutical company, and the hard problem is not so much the connections, but making sure that you can actually compare the numbers that you bring together.
Yeah, so I was compressed with time. I mean, this could have easily been a 40-minute talk, and unfortunately we didn't, so we couldn't really go into there. But just like you're asking when you're packaging up a data product to describe the semantics, which was one of the principles, the shared terms, like these are the semantics. And even there, you're looking to say, well, has someone already defined these terms here? So should I be reusing someone else's terms? Which is part of the data integration problem. But the second bit is doing the links. So you're responsible as the data product owner for reaching out to other data products which make their data available as URIs, and then you have to have an entity resolution service, which is basically mean that this data product, I've maybe got the first name and last name of the person. I have to kind of go out into the distributed knowledge graph, and I give the first name and last name to the person data product, and that will return me back the unique URI of that person. And then when I'm making my data product available, I don't make it with first name, last name. I make it with the connection, which is the URI link, which is exactly the same thing that's worked out on the web, right? So basically my data, we transfer the responsibility of doing the data integration from the people who are consuming the data to the people who are producing the data. That's the kind of trick that we're doing here we're doing decentralized organization, which is decentralized data integration. So it's on the data publisher now to provide accurate semantics describing what their data is. It's on the publisher to go out there and link into other data products. And then when the consumers want to come in, they don't have to do any of that data integration work. So basically, that's what I'm saying. It's a lot of work, but you're now kind of pushing it out to anybody that's got data. If your application's got valuable data, you are now obliged to make that available as a data product, and you need to then create the links yourself.
One last quick question here.
Thank you, Tony. Great talk. My question is really to maybe appreciate the journey and the current state of DPROD. Is it something early stage, or do you have sort of relatively large scale companies, i.e. lots of data silos actually getting value out of DPROD?
Yeah, so it was DPROD was kind of birthed in production, if you know what I mean. It was birthed in a large Swiss tier 1 investment bank. And it's subsequently been rolled out to other investment banks as well. So I think, I mean, I come from the finance background, so maybe that's why that it's proliferating most within there, because that's part of our community. But also, I think the finance community, you know, we know about markets, so it comes very naturally for us to kind of think about that. And LSEG have also adopted it. So and there's a really interesting thing there where the investment banks will then have their DPROD, which is creating their internal data market, and then organizations like LSEG, and I was chatting to the Bloomberg people as well, makes total sense for them. They can adopt the same data product standard, and then within the internal data market, I can now go and find external data as well, which, you know, maybe if it's valuable enough to me, it makes sense for me to just buy that. So it's like kind of reducing the friction there. Yeah, it's very active, and we did like a kind of year of working with the vendors. There's a whole bunch of vendors which are hopefully going to be implementing it as well. So yeah.
Thank you, Tony. Great presentation.
Thank you.